Hello guys, it's Dr. AJ. So we have a Truss example. It's very common in the FEMP exam and it's really one of the simple questions. So you don't want to miss questions like that. So let's get started. As you can see here, we have a truss and it's required to find the reactions at C and E and then the forces at member AD, BD, and CD. So the first thing we do is just to put the forces, the reactions from the support. We have a pin-pin support, and as you can see in the pin support, we have two types of resistance in the Y direction and the resistance in the X direction, as you can see here. And so we have EX, EY, CX, and CY. You don't have to put them in the right way from the beginning. It's just an assumption. So for the CX and EX, we assumed it to resist that way against the X direction really, and then we assume the Y for EY and CY to be directly, and as I say, you can assume them to be downward. I would say it's just more, it does make more sense to put them upward just because we have the 3 and 4 going downward so to resist them. So let's do the equilibrium for the truss to find the reaction. This is for the entire truss. So first of all, we do the summation fx equals 0. We basically assume going rightward is the positive sign. So what we have in this really, CX and EX, those are the only two components in this equation. So minus CX, just because we assumed it to be going leftward, which is the opposite of the direction of the summation fx we assume for. That's why it's minus CX. EX is the same as well, it's going left. So we put a minus equals 0. That's equation number 1. Equation number 2 is summation of y equals 0. So again, we have CY going upward. It'll be positive. That's an assumption. EY, it's positive as well. And we'll be resisting 3 and 4. And they're both in the negative direction. So with that, it's going to give us EY plus CY equals 7, which is equation 2. The third equation we have for the equilibrium is the summation moment. So when it comes to the summation moment, really, it doesn't matter where you want to take it, but always keep in mind you want to take the moment where you can eliminate as many forces as possible. So if you put the moment at E, it will be good as well, just because you will basically eliminating two forces, EY and EX, from your equation. So that will basically foster the way to determine the CY and CX. What I did is basically I did the moment around C equals 0. You can take it in D as well, but that will complicate the problem a little bit more because all the 4 combination will be there, EY, EX, CX, and CY when you take the moment here. That's why I think E or C are your best option really to find the moment. So we take it on C really. So EX, that's the first one, times 6. This is the arm, and it's positive because it's clockwise. This is EX, and it's going that way, right? It's going that way. So the fastest way I think to determine if it's a clockwise or counterclockwise is basically, for example, here we have the force EX. I go to the point where we're taking the moment about, which is C in this case, and try to add a force that is the opposite of EX, and then do a rotation. When we do the rotation here, let's say we have a force that way. Let's say it's CX, and CX is not this way. It's basically the opposite of EX is going that way, right? It's going to the right. So now when we take the moment around C, you'll see like it is doing that way. It is a clockwise, right? And this way, and since we assumed here the clockwise is positive, so EX times 6, it has to be positive. Now we go to the 3. That's the force we have, times 8, the distance from the force to the point of rotation, right? So now it's positive or negative. It's going downward. What we're going to do basically, we put a force that way going upward. So if this is going upward and this is going downward, that means what we have here is basically a counterclockwise. That's why it's negative. Again, the same with 4. The 4 is the force, and then times 4 is the distance. It is a counterclockwise. It's going that way, that way. So Doing that, that's going to give us basically EX equals 6.67. It is positive. Our assumption is right. So we can go ahead now and find the other forces, EY, CX, and CY. So we have 4 variables and we have only 3 equations. So does that make sense? No, it does not make sense. But it works. Why? Because what we did first, if you paid attention, we did the equilibrium for the entire truss. We did not do it internally. So in order to find the other forces, we have to do internal equilibrium. And that will basically gonna give us the other forces. So from E sub x, basically 6.67 from equation number 1, if you substitute it, we're gonna get E Cx basically equal to 6.67. And if you solve the equation, you will see like minus Cx equal 6.67. So that means Cx is basically a negative number. So Cx is negative just because we assumed it going leftward, and the reality is it's going that way. That's why. So it's up to you. You can keep it negative and it's directing that way. So when you keep it this direction, but you put Cx equal minus 6.67, or you put it 6.67 and you flip the direction from going to left to going to right. So now we find Cx, what we're going to do, the equilibrium, the internal equilibrium, so that we can find Ey and Ex. So what we did basically, we went to the joint E. Why I took joint E? Just because we are trying first to find Ey. So you take the joint E and you can see Ex, we just found that. Ey, we still want to know that, but we don't know the forces in the member ED, right? We don't know that. So first, since it's a diagonal member, you're going to be using, it's a resultant, so we have 2 components, component in x direction, 4 over 5 ED, and component the y direction. So in order to find the component, really, we have to know the angle, or basically the magnitude of those angles. So for this one, it's basically 3 is the vertical side, which is basically this one. 4 is the horizontal side, and then we can use the Pythagorean to determine really the chord length. So 3 squared plus 4 squared and their square root, that's going to give us really 5. So first, I assumed the force in the member ED to be in compression. You can assume it to be a tension, nothing wrong. If you get a negative result, that means it is in compression, not in tension. So it's just an assumption. So if you do the assumption and you assume it's a compression, you're going to get a force that way and a force downward, right? So the x component is basically 4 over 5 horizontal over the chord, and then the vertical component, it's basically the 3 over the 5. ED. Now we can do the equilibrium. So which way is the better to do the equilibrium? Ex, summation of x first, or summation of y? Well, if we do summation of y, we're not going to be able to find it directly just because we don't know Ey and we don't know Ed. So it's not going to work. It will complicate it. But if we do summation fx, we already know Ex, and we already basically have the component 4 over 5 Ed. So we can get ED really quick, and then we can apply summation of y because we found ED in order to find EY. So as you can see here, do the summation of x equals 0, and it's going rightward. So we have this component 4 over 5 ED, and it's positive because it's going rightward, right? Minus 6.67, which is the reaction. It's going the opposite way. 0, that's going to give us ED of 8.34. It is in compression, so we can now apply summation of y equals 0. Now we know ED, it's basically we're going to be able to find EY, and EY is equal 5 kip upward. Now we found EY, found EX, the only thing left is CY. Now we have all the reaction except CY. So, but we're going to go back to equation 2 to find that, which is EY plus CY equals 7. We just found EY. We're going to be able to find CY. That's going to give us a CY of 2 kip upward. We're done basically with with the reactions, we're going to go ahead and determine the forces in member AD, BD, and CD. Let's start with member AD. So the best way to take it is basically to cut a section that way. You're going to go ahead and just try to cut a section. So this is basically what you're going to see. The force 3 applied. This is A. This is the member we're trying to find the force in. And there's the member here, B. And then the second thing, since it's a diagonal member, every time you have a diagonal member, you have to find the angle or the component of that angle. So again, it's 3 for the vertical and 4 for the horizontal, and the 5 is basically the chord length or the member length. So again, just because the force was downward, I would assume there is a resisting force going that way. So that's why I assume compression. If you assume tension, there will be no problem really. All what you're going to get, it's a negative result, and you can basically say this is not tension, it's still being compression. So now we have the force AD, the component on the y direction, and the component in the x direction. Again, two equations, summation fx, summation fy, to find those, because this is internally, so you can apply the equilibrium equation on them. Here we have two options. Either apply summation fy or summation fx. If we apply summation fx, it's not going to work. Oh, let's say it will complicate it. Why? Just because there's this component, we don't know AD now. We're trying to find that. And then there is another member here, AB, which is this one. We don't know that. So in order to find AD, we have to find AB. Did that make it a little bit longer procedure? We don't want to do that. We can go with the vertical, though, summation Fy, and we can find the force in member AD. So if we do summation Fy, you will see that we have only the 3 and then 3 over 5 AD. And that's going to give us basically AD. Summation Fy equals 0. 3 over 5 AD, it is positive because it's going upward, minus 3 because it's going downward, equals 0. That's going to give us AD of 5 kip. It's in compression, so the assumption is right. The second member is BD. It's this one, and it's really, this is one of the simplest because you're going to take this joint and it will look something like that. You have the 4 kips, it's applying downward. This is the force. Again, I assumed it just compression just because to resist the 4 kips applied on the joint, and then you do the cut. Summation Fy equals 0, and that's going to give us a BD of 4. If there was no force here, that will be definitely, this member will be a 0 member. The final member is member CD, which is this guy. So this is basically how it looks like. If you take a section, you'll see this is the joint C, this is the member B and D. And then again, just because it's a diagonal, I would always put the angle or the component of the angle. I assumed it to be in tension just because this is the reaction is resisting that way. So I can just put it, there's some tension in that member. Again, you can assume it to be in compression. So we have all the reactions, and then now we can basically do summation fx, summation fy. Which one to choose? If I would use summation fx, again, we will have to find the member BC before we're going to be able to find CD. So let's avoid the summation fx and we go with summation fy equals 0 because we have the vertical reaction. That's basically, we found that a minute ago. And then we have this component 3 over 5 CD, and that's going to give us basically the right number. So 2 is positive because it's going upward, minus just because it's going downward. We assumed it to be in tension, and we got 3.34 kip in tension, and that was the force for that member. So we found the reactions, and then we found the forces in member AD, BD, and CD. With that, I think we're done with this example, and let me know if you want me to cover a specific topic. Thank you very much, and don't forget to hit the like button and hit subscribe. Thank you.